This unit, we're going to be looking at trigonometry, and we're going to be dealing with triangles. This is actually a geometry lesson, but it's something that you're actually going to be familiar with. We've talked about quadratics, and this is a good lead into trigonometry. But before we even get to the big meat of the trigonometry, we need to talk about just an intro. Specifically, we're going to be looking at similar right triangles. And there's some information that you need to know ahead of time in terms of definitions that need to be brought to light before you actually get into the big meat of trigonometry. For starters, we have acute, right, and obtuse. These can be either angles or triangles. The denotation here for an angle is like this. Sorry, just used to having people know what it is, and you might not know. An acute angle is an angle less than 90 degrees. So it's from 0 to 90, but it cannot be 90 degrees. To give you a picture here, right here would be an acute angle. A right angle is 90 degrees on the dot. And it'll be denoted with a right angle notation, which is actually a perpendicular. An obtuse angle is anything larger than 90 degrees, but less than 180. That right there would be an obtuse angle. Now, when we're talking about lettering for an angle, there are specific ways in order for you to label this. B is what we call our vertex. And with that, when we name this angle, the B has to be in the middle of your combination of 3 letters. So this could be angle ABC or angle CBA. So if you notice here, both of these angles have B in them with the middle letter, which is what you have to have. That tells you where your vertex is. That tells you where the angle is formed. Generally, I like to stick with using 3 letters just so you kind of have an idea in case something were to change that up. The next thing that we're going to be talking about here are corresponding or our actual similar triangles. All right, similar triangles have 2 conditions. First condition, the side lengths are corresponding, and we'll talk about what corresponding means in just a minute, are corresponding and proportional. The second condition, the angles are corresponding and the same angle. Like I said, we'll actually look into this a little bit more right now. This just kind of seems confusing. But looking at this, Okay, so when we're looking at this, we need to figure out what the corresponding sides are, corresponding angles. Okay, so what does this mean? This means I have to match up the correct letters and see where they're at. So looking at this, and notice here, I'm just basing it off of, right now I don't have any side lengths, which is fine, but I'm just want you guys to get the idea of what we mean to be similar. Looking at this, the 30 degrees is with angle DFE, where this 30 degrees is with angle BAC. So notice there our vertex was the A and the F. So we're going to say that A corresponds to F. Now let's look at the 90 degrees. The 90 degrees, if you notice, the B and the E correspond, which then leaves C and D corresponding. So if that's the case, then I know angle BAC corresponds to angle. Now notice here, when I write this out, the B and the E have to match up. So I couldn't put it as how I see it as DEF or DFE. I have to make sure that it corresponds with the correct lettering. So it's going to be EFD. Okay, and the same goes for the side lengths and the other angle measures. So that's how we look at how to find the corresponding angle measures and the corresponding sides. So for instance, if I was looking at the sides, DF corresponds then to CA. Again, I didn't even have to look at my picture. Now that I have this little key here, I just have to write down the lettering for it correctly. In terms of proportions, let's look at two triangles here. So if you look at this, UW has to match up. UW has to match up with, sorry, I forgot to write the letter, RT. Now, VW then has to match up with ST. All of these proportions have to be the same. So if you look at this, I went with this, you could do it the big to small, but I did it the small over the big. So the smaller triangle to the larger triangle. So if I'm looking at this, trying to figure out R here, I've got 6 over 7 has to equal 3 over R. So looking at this, I know that I'm going to multiply both sides by R, just solve this algebraically. Get R 6/7 equals 3, divide by that 6/7, and R would equal 7 over 2. You can type that into your calculator and solve for that. So that's how you figure out your proportions, as well as looking at your angle measures and how to write your corresponding parts.